G'day everyone. Thanks for the introduction there. I'm Burke, as we said, and yeah, solutions engineer at HashiCorp. So normally I have a bit more of a haircut. I'm due for a shave tomorrow, so I go back to my normal self. But that's my normal form. Anthony Burke is my name, but everyone just calls me Burkey. I think my mum calls me Anthony when I'm in trouble. So yeah, just Burkey. Um, been at HashiCorp for nearly 2 years now. I think we have Dave and I started similar times. Coming up to that 2 year mark, which is the part of the a quote old guard, and excited to work with customers deploying various HashiCorp solutions. You can find me at pandem underscore on Twitter as well. So today we're going to go through and talk about some of the pieces of the puzzle required about putting it together for a multi-tenanted Nomad cluster. Now, this could be multi-tenancy for in terms of multiple business units owned by the same business, or it could be multiple customers and you're hosting a scheduled platform. We're going to do a bit of a recap, go through these pieces, and give you some takeaways that will essentially amount to where these pieces fit in the puzzle and also what I'm going to use to get started. So if you were looking to provide a Nomad cluster, where namespaces are applicable, where to use resource quotas, where to provide network isolation, and where to provide multi-tenancy in my network space. And from that serve as a springboard into getting it done, getting on with it. If there's any questions, as Pete and Dave mentioned, just throw them in the Q&A section. We can potentially live mic at the end, but more often than not, they end up being answered pretty quickly. All right, so let's get started. So let's go to a quick 30-second, 1 minute overview of what Nomad is for those who may not be familiar with it, and we'll go on from there. So Nomad is one of HashiCorp's products that is designed to provide consistent scheduling and runtime orchestration for containers, but not just for containers, but also application runtimes as well. So you could, for example, run a container being a Docker or Podman based container, have it running adjacent to and scheduled the same way as a Java runtime, a .NET runtime, a locally run file, and bring to those traditional workloads all the benefits to the reasons why we use schedules and orchestrators such as Kubernetes or Nomad. And this allows us to provide consistency in the way we deliver applications that are of the traditional runtimes, the Javas, the .NETs, and the things that haven't been refactored yet or will never be too expensive or too hard to refactor, and running them adjacent to the more newer technologies such as container-based runtimes, where we have our applications all in containers and we're splitting up dozens of web front ends, that sort of stuff. So Nomad is our tool there, which ties nice and neatly into Consul, into Vault, and whatever that be on premises or on cloud. Where Nomad also likes to play is that we provide this consistency for underlying OSs that are Linux, Mac OS, and Windows as well. So no matter what that OS you use, we can provide scheduling functionality on those operating systems, which allows, for example, the usage and driving of IIS workloads or Mac OS based workloads, which is pretty sweet. All right, so let's talk about the first piece of any tenancy strategy. We're come into namespaces. So namespaces allow the segregation and separation of objects. Now, objects in a Nomad context are things such as the jobs themselves, so the actual runtime being scheduled. These could be storage allocations. These could be users. These could be the different permissions, are all grouped under a namespace. So, for example, that would be Pepsi, Coke, water, and under that hierarchy, you would have the jobs, Pepsi web, Coke web, water web, and then they would only be seen to the administrators of those particular tenancies, right? And me being Berkey as an administrator of all of the tenancies, I could see all three potentially, and that provides us the ability to give differentiation to different customers or different business units. That means then we can say, as I log in, I'll see what is associated to me and provide isolation for that job. It also provides an administrative boundary. That administrative boundary is important sometimes for compliance reasons, for security reasons, in terms of access and control. But it does pose some platform challenges at which you need to be concerned about, such as how do I control that, given it's a shared platform, how do I provide that, Pepsi isn't going to take away all of the resources from Coke, or is water going to consume all the storage from the other tenancies, which we call the noisy neighbor, potential noisy neighbor problem and resource eating problem. Noisy neighbor problem focuses around, will another tenant drain the existing resources, or cause agitation in the underlying operating systems. For example, if this is a virtualized platform, you could be taking potentially all of the CPU usage or providing different consumption of memory that could impact other workloads. So how do I control these scenarios? And we'll cover that off shortly. So the approaching namespaces is API based, or if it's CLI based, or even within the job spec itself. Creating a namespace is very straightforward. Nomad namespace apply, give it a description, and then do the name of the namespace itself, right? Straightforward application, which would then have my cluster start to look like this. Here I have two namespaces, which has jobs in the logistics and dev namespace, and I have a job in the RD dev namespace, which means that if I log into that environment, I'm not going to see those other jobs. Right, very straightforward process. That logical isolation provides that hierarchy and that isolation. Resource quotas. Now, we want to make sure that the reality is, that not all workspaces and namespaces are equal, right? If you look to any environment, there'll be others that have a gold, silver, and bronze tiering strategy, or whatever, platinum, diamond, whatever tiering you want to use. But resource quotas allow us a way to provide limits of resources to an assigned namespace. This means operators of the platform can attest and assign a various number of resources to a namespace. This could be the CPU megahertz, storage, memory allocation, right? And this allows us to do a couple of things. One, it puts a safeguard and railing around the namespace itself. It protects the workspace from draining other resources. So for example, in my Nomad job file, nothing stops me from writing 100 gig for memory, right, in my job. I don't know, I need 100 meg, and I've done 100 GB as opposed to 100 MB, which, whilst it's a few keys across on your keyboard, you've potentially misallocated, or you've done 1,000 megabyte as opposed to 100 megabyte, right? And that means that you're going to, no one's going to try and schedule it. If those resources are available, it will try and schedule it for you. Let's say there's 102 gig available. All of a sudden, you've just consumed a whole heap of resources that you don't actually need, but they are allocated to you, right? And so what this does, that can potentially, based on your there are ways to force evict other workloads and other things like this to control the environment. You can potentially interrupt legitimate workloads through a misconfiguration. So resource quotas help avoid this sort of thing. We want to avoid exhaustion of those resources, and it's a great way of assigning a known maximum. In multi-tenant environments, depending on what type of business you're in, this could also be a cost metric, or it could be you unlock a gold tier environment, which is you guaranteed more resources. And that way you can start providing a hierarchy on those environments, which is another way of, from a business point of view, that people assign things like, a production tier has a lot more than a dev tier. Like 1,000 dev tiers have 1 gig of memory each and 1 gig of storage and 1 core CPU. Yet production will have 100 cores of CPU and 100 gig. Right? Whilst these are arbitrary numbers, you sort of get the idea of what can be done. So how about the resource quotas, right? So I can initialize the quota spec. So Nomad quota, and it will generate me a HCL file, which will have the quota spec in it. I'm going to go into that quota spec and name it default quota. I'm going to assign the limit. You can see here, the region is production. The limit is 2500 megahertz CPU and 1000 meg of memory. You must excuse me, I'm jumping on mute to cough, not to blast your ears away, but also getting over the joys of lurgy in winter in Melbourne. And so you can see here it describes what it is and it will apply to it. So that means then I can guarantee that this production region is going to have this, and that it can't exceed it, it can't drain resources from other regions, which is happy days. And that will then allow me then to ensure that I can apply that to that specific workspace. So what I can see here is that I've applied a resource quota to logistics and dev namespace, and I've then applied another quota to the R&D dev workspace. And you can see here they've got different values. So here we can start building out the different size blocks in our environment for the boundaries of which we put our workloads into. The consideration here around resource quotas, I'll have a note, this is an enterprise feature of resource quotas. Namespace is open source, resource quotas is enterprise. I'll call out what's appropriate there. So ACLs and policy. Now, within a tenant, it's important to provide. The reality is you might have a tenant where there is mixed workload. And when I say mixed workload, they might be of different trust domains or different or administrative permissions or different groups. There might be an operators group, there might be an auditing group, there might be a admin group, for example. How we can control one, access to the platform, and then two, what those people can do, or those operators, and that could be an API or a user, is through ACLs and policy. Now, ACLs are the engine that provide access. So it's a token-based system, and the ACLs grant access to various things based on that token. So we'll give a subset of permissions. I can read, I can write, I can update, I can delete various things in that namespace. So you can, traditional RBAC model, you can see that an admin will probably do everything, an operator can read and submit jobs, an auditor can only read everything, right? Or pull data out of that system. So that policy then is then applied to the token. So I generate a token called Burke. That Burke token is a part of a role and that or policy, and that policy will derive what I can and can't do. And these can be scoped to the namespace. So you can see where I'm going with this one, right? Is that here is my default read policy, right? So namespace default, it can be namespace R&D dev or namespace Pepsi or Coke. Policy read. Capabilities are submit job, dispatch job, and read logs. So I can submit a job to Nomad, I can dispatch it to the scheduler, and I can read logs. I can't change storage, I can't read storage, I can't view storage, I can't read nodes, I can't assign nodes, I can't modify node properties, right? So it's very much a very rudimentary basic job. But if this was a pipeline or an API tool accessing Nomad to schedule a job, perfect, right? All you gotta do is take the job and apply it to the API and away you go. So that's all it really needs, right? And I've hit end on my presentation. Good work, Berkey, there. Let me go back to the when I get excited and wave my hands, look at that. And I'll go present. You can see that there's a number of different roles, right? So I click next, not end. And you can see here, there is the policy and then the capabilities. The policy is the broad spectrum, read, write, scale, delete, or deny, right? Underneath that banner, there's more specific. So I can assign Berkey, you can read Berkey, and Dave, you can write, and Pete, you can scale. But if sometimes there might be times I need to customize this. Hey Berkey, I want you to read, but I don't want you to read CSI list volume or CSI read volume. So I'm going to give you manually list jobs, read jobs, list scaling, read scaling, and read job scaling. But you know what, Berkey? I trust you, and your job requires it. I need you to be able to. I need you to be able to scale job. I need you to be able to list scaling policies. Perfect. So I can actually give you those capabilities in addition to what you've got. So I can do the read stuff, I can do some scale things, and maybe I can do alloc exec under write just because that's what I require. And so you can get these really nice granular permissions, which allow me to have then different personas within my namespace, which is a way of us controlling who can access what, which provides a sort of a subtenancy model. And you can see there I've applied different namespaces, default read, and then write plus the submit job capability. Gives you an idea of what you can do. Again, this is not recommended practice. These are just approaches and things to get the thinking juices going. Networking. So what are my network options with Nomad? Nomad has ability to use the Container Networking Interface, or CNI, as of Nomad 12. This provides, the CNI framework provides a consistent, standardized way for network vendors to provide plugins for container-based networking. It is consistent behavior from different approaches. And when I say different approaches, this could be the way you do, the CNI integrations are various. They're Mac and Mac or VLAN networking or overlay networking. Back in my day in the Kubernetes space, it was the NSX plugin. You had a Palo Alto plugin. You had all very different vendors doing things under the CNI framework. So Nomad now takes advantage of this, which is great, which means I can build container-based applications that have multiple NICs, private networking, public networking, all of those funny things you may need for certain types of workloads. In addition to the CNI, we have Consul Connect. Consul Connect allows us to use HashiCorp Consul to build isolated fabrics on top of the infrastructure that is independent of the host networking. And I'll show a topology of this shortly, which allows us to provide per tenant and per application topologies, building out containers and sidecars or applications and sidecars and meshing them together and allowing them to take on access on demand. This is independent of that host networking, right? And what tenant A does doesn't matter what tenant B does. The third option of networking in Nomad, I'd be remiss not to point out, is host and bridge networking. But in the context of a multi-tenant discussion, using a host network wouldn't really be suitable because you're all using the same endpoint. But if you did, you most likely have a load balancer listing on that port. So it wouldn't be just used for like, here's my application on the host port, but here's my application behind a load balancer, and that load balancer provides access. So it's probably the least preferred option in this case, but you do have the CNI and Consul to talk through as well. So from a Consul perspective, what does that look like? And I'll focus on Consul because this provides the most flexibility. Consul, here's an example of a single job. So I have two Nomad nodes. I have a job scheduled, which is just it can be a container, it can be a runtime, it can be .NET, I don't mind. A Consul sidecar is spun up on that and is associated with that job. What it will do is Consul will connect these two jobs together. It's the same job. It knows that, hey, this is the same job. I've got multiple deployments of it. Connect these two up. And it's going to be a TLS connection to each other. So any communication to each other done via service discovery will connect each other, be encrypted communication, and ensure that any communication occurs over that network, is just for those applications. If I spin up another application on this node, it's not going to be able to talk to these two machines. I have to, via egress, get egress out and come in via load balancer to act like a normal traffic would to access the application. If I have multiple jobs on the same infrastructure, I've just done a black job, a purple job, and a green job, you can see here that they use the same infrastructure, but there's three distinct application fabrics, for lack of a better word, where communication to each other and north-south would have to go out via a load balancer, or but with it, once you're on that black network or that purple network or that green network, you would be within that fabric, and only permitted communication can occur between green to green or purple to purple, and they can be on the same host, or that can be across different hosts. So it helps simplify building networks on demand for that specific application. Secrets. Now, this is probably one of the other parts of tenancy that it makes it hard, is that to provide secrets for multi-tenant environments, having ability to provide per namespace secrets, ability to consume secrets from Vault is a way Nomad can do it. There are other solutions that integrate with Nomad for secrets, but Vault has a very nice native one, and I'll cover it through here. So there's two parts. One, the scheduler itself, accessing the tokens we discussed from the ACL engine before, and then the job template renderer. So when I render a job against Nomad, it goes to Vault to retrieve the secret. So Nomad node configuration, I'll point the server to Vault. It gets done generally by the platform owner, right? This would be more suited towards, more suited towards a single owner, multiple tenancies inside that, as opposed to a public multi-tenancy system. And then there's a Vault configuration of build the Nomad engine, you build the Nomad configuration roles and tokens. I will gloss over this one a little bit here. So what we're going to see here is the request to access Vault. The request is going to hit Azure AD to log in to Vault. The Nomad role says you can access Nomad accordingly, and it's going to program Nomad with a token and retrieve that token back to that end user. You can see here that token gets read back, and then I can, as that requester, submit that job to Nomad. Fantastic, right? Which is a great way of doing the ACL stuff on demand, which is super. The alternate thing is I can, instead of just doing that, I can now have a valid token. I can submit jobs against Nomad, and Nomad's going to actually ask Vault for the relevant tokens where I've rendered this template. So you can see here, I've got a number of credentials. Here I've got some go read database creds access database, and then populate the response into this password field. It will go submit the job to Nomad. Nomad will chat to Vault. Nomad will retrieve that Vault engine. It's also going to program that particular container accordingly based on this template here and program it for me, which this helps me eliminate some of that complexity around secrets and tenancy environments. In addition to that, you can see here there's the output being rendered. So in summary, looking at this here, I noticed there's a question in there from Vinod. So we're going to cover this off. So we've got namespaces for object isolation, your Pepsi, your Cokes. We have access and roles to say, hey, I can do X inside a tenancy, or I can do X across multiple tenancies. I have resource quotas to control access to how much people get access within in a tenancy. How much CPU, how much memory, to ensure that there. I have multi-network and multi application networking provided by Consul and CNI, so other networking providers as well, which gives us a bit of flexibility. And then I have the ability to control secrets as well on demand, which is super, super flexible. So Vault, Consul and Vault support Nomad, but Nomad on its own provides a great platform for scheduling non-container and container runtimes. And when the discussion regarding tenancy or multiple users are concerned, we can handle those scenarios. So the service of today's session was to provide you, these are some of the building blocks I can use. From here, I'd recommend going to learn.hashicorp.com or the documentation for Nomad and reading a bit more about these features. There are other HashiCorp sessions we've done. I've done specifically on Nomad as well that pertain to this, but feel free to reach out anytime.